Hello everyone, very good evening and welcome back to all of you. So first of all, let me ensure that whether my voice is clearly audible or not and my screen is clearly visible to all of you or not. Just please let me ensure that. Yes, is that all okay? Okay. So thank you very much you all. And this is our sixth session for our advanced level, and till this time we have completed about many of the things. And in our previous session we had a discussion about how to calculate the wind load for your structure and then how to assign in your proposed structure. So basically you have to change the load type of the window from the ETABS templates to user defined load pattern. And after doing the calculation by your spreadsheets, you have to put the values here in your software. So for the x direction, for the y direction, how to do the calculation and how to put in your software, that we have discussed in detail in our previous session, right? So now the next point we have to discuss, so let me mark it here as completed. So we are filling it by the yellow color to make it as completed. Now the next point that we have to discuss about the Modal analysis. So yes, all the materials and everything I will upload. Don't worry, all the materials you will get, all the study materials, practice materials, everything you will get, whatever is necessary for your learning. Got it? So shall we start the discussion for today's topic? Okay, fine. So you might have observed that since from intermediate level or even in the beginner level also, you have practiced with a sample project in the beginner level. In intermediate level we have completed the uh, medium rise structure, and in our advanced level we are dealing with the tall structure. So one thing you might have noticed that when you are going to see the load cases, go to define, here the option is load cases. Once you go to the load cases, one load case or load format will automatically be available here as Modal. Here as one by default load case will be available as Modal. So whenever you are going to initiate any project in your ETABS software, so ETABS software by default giving this Modal load case or Modal analysis you can call it too. So if you are going to open your intermediate model, you will find this. Although we have not discussed this point, we were not intentionally want to have this Modal analysis in our project, but still ETABS software is giving it by default. In your beginner level, if you are going to see your sample project, there also this Modal analysis may be present. So what actually the meaning of this Modal analysis, today we have to understand that. So your Modal analysis is a type of analysis in which we are going to find out or we are going to look at the dynamic behavior of your structure, dynamic response of your structure with its inherent capacity. What is the Modal analysis? It is a very simple. We would like to know the dynamic response of your structure, dynamic behavior of your structure. If you are going to excite your structure or if you are going to put any intensity of the load, instant intensity of the load, if suppose you are going to put over your structure, okay, sometime we are calling it as jerk, okay, or constant load, if suppose you are going to put. So in any of the type of the load, if you are going to put over your structure, so how your structure is going to behave, how your structure is going to respond, that is what called as what? Modal analysis. Is that all clear? In simple example, if suppose let's consider in a simple example, if a classroom is there where the teacher is present, student is present, for an example, and if suppose a student is going to do any kind of mistake, if any kind of means unwanted thing were going to be done by your student, so teacher what is going to do? Teacher is going to shout on him, yes or no? Agreed? A simple example. Hello. Yes, teacher is going to shout on him. So if the teacher is going to shout on him, so that person, that student, how it is going to respond? His teacher is likely going to tell about his mistake, so his respond will be calm. When it is going to start shouting on him, so his response is going to be changed. It may be crying, it may be in anger. So what is the response of that student when the teacher is going to shout on him, when the teacher is going to make the explain his mistake? So that is what we are going to observe, the response of that student. That is what similar to your structure. When you are going to impose the load over your structure, how your structure is going to respond? कैसा आपका structure response करेगा? What will be the behavior? How much it is going to deflect? How much it is going to rotate? To what speed it is going to vibrate? Whether it will collapse, whether it will not collapse, whether it is going to uh, uh, respond with its entire integrity as a as a overall structure. Globally the structure is going to respond to your applied load or not, or some part is taking the load, remaining part is not taking the load. Only lower floor of the building is going to respond rigidly, and upper floor of the building is not going to respond in accordance to the lower floor, or the top floor is going to respond effectively, lower floor is not going to respond. So this is what the behavioral study we are going to do under your modal analysis, how your structure is going to respond. And obviously to understand the response of your structure, we will set some parameters. आपको आइडेंटिफाई करना है, तो सपोज लेट्स टेक अगेन द एग्जांपल ऑफ दैट स्टूडेंट. सो अगर आपको उसका ओवरऑल रिस्पांस एनालाइज करना है, सो यू विल कैटेगराइज बाय द डिफरेंट प्रॉपर्टीज, by his face, okay, by his eyes, by his body language. So these are the different parameters by which you are going to understand. So see, the same thing will happen with your structure also. So to understand the behavior of structure, how it is going to respond, we are going to find out some dynamic properties of the structure. आपको क्या पता करना पड़ेगा? आपको dynamic properties of the structure find out करना पड़ेगा. Like suppose I am giving three structure A, structure B, structure C. So if suppose you are going to apply the intensity of the same load to all of these three structures, so how the structure is going to behave, that is the overall concept, overall thing we need to know. But we need to set some parameters, like first structure, how much it is going to deflect, second structure, how much it is going to deflect, third structure, how much it is going to deflect, whether first structure is rotating or not, whether the second structure is rotating or not, whether the third structure is rotating or not. If suppose vibration is there, what intensity of the vibration is. So this is what again I'm telling you, it is a behavioral study. So what parameter actually, these all are the general things just to understand. Now in reality, what is the modal analysis? So modal analysis is the analysis where we are going to look at the behavior of the structure under the application of the loading or under the excitation, okay, and that is going to be find out with some of the specific parameters. The first parameter will be your fundamental time period. Fundamental time period. To complete one oscillation, one rotation, to complete one oscillation, to complete one rotation, what time is required for the building A, building B, building C? So if you are getting the fundamental time period more, means building is less stiff, means deflection is more. Are you getting my point or not, or it is difficult to understand? Yes or no? सिंपल है ना. क्या करना है आपको? बिल्डिंग का बिहेवियर फाइंड आउट करना है, तो टाइम पीरियड मालूम कर लो. टाइम पीरियड आपको बता देगा बिल्डिंग को कितना टाइम लग रहा है एक ऑसिलेशन कंप्लीट करने में. फर्स्ट थिंग, उसी टाइम पीरियड से आपको ये भी पता चल जा रहा है, इफ यू आर गोइंग टू कंपेयर थ्री बिल्डिंग्स, जिसका बिल्डिंग का टाइम पीरियड ज्यादा है, मींस इट्स अ डिफ्लेक्शन इज मोर. आर यू गेटिंग और नॉट? यस. उससे समझ में, अदर पैरामीटर्स को कांस्टेंट रख रहे हैं. वी आर मेकिंग अदर पैरामीटर्स सेम फॉर ऑल अदर स्ट्रक्चर्स, मींस ऑल दिस थ्री बिल्डिंग्स. ओके, वी आर स्पेसिफिकली फोकसिंग ऑन वन पैरामीटर. देन फ्रीक्वेंसी, to what speed, to what speed the building is going to vibrate, the building is going to oscillate, that is the frequency we need to know. So fundamental time period, oscillation and integrity of your structure, आपका ओवरऑल स्ट्रक्चर पूरा पूरा के पूरा ओवरऑल पार्ट ले रहा है कि नहीं आपके लोड को रेजिस्ट करने में. मैंने आपको भी एग्जांपल दिया, ऊपर का फ्लोर तो रेजिस्ट कर रहा है, नीचे का नहीं कर रहा है, नीचे का फ्लोर कर रहा है, ऊपर का नहीं कर रहा है, मिडल का पार्ट स्टिफ है, ऊपर नीचे का आपने लेस स्टिफ बनाया हुआ है. सो देयर शुड बी यूनिफॉर्मिटी इन द स्टिफनेस ऑफ योर स्ट्रक्चर फ्रॉम बेस टू टॉप. सो आपको ये पता करना है कि आपका बिल्डिंग पूरा स्टिफ है कि नहीं. सो आपको मॉडल एनालिसिस के थ्रू जाना पड़ेगा. So this is what the modal analysis, we are going to find out the dynamic inherent property of the structure. Dynamic means dynamic response under the application of the loading for a specific time period. Okay, that is a dynamic response. And inherent property means the property means time period, frequency. ये structure की खुद की property है. And yeah, one more important thing is nothing but your damping. What does you know the damping? Can anyone tell me fast? Damping का meaning क्या है? Yes. What does you know the damping? कुणाल, अश्विन, damping क्या चीज है? मैं आपको फिगर के साथ सारी चीजें एक्सप्लेन करूंगा, but overall I am giving the idea what is the modal analysis. So tell me what is the damping? Pandian, Madhura. Absorption of stress? No. Damping, it is opposite other than of energy. No, you are close to the point but not exactly the answer, and right answer you are not giving. Related to fire? No. What is the damping? क्या है मीनिंग, क्या है डैम्पिंग, है क्या चीज? यस गाइस. Restraint to external effect? No. Restraint to external effect? No. Ashwin, very simple it is. Okay, take an example. Suppose a building is there, I am going to excite it, resistance to vibration. Vivekanandan, close but not right. Resistance to vibration, that is another thing. Let's say it may become a stiffness. स्टिफनेस से ही हो जाता है वाइब्रेशन के रेजिस्टेंस करने के लिए. नहीं, ठीक है आपका पॉइंट, बट इट इज नॉट राइट. Okay, what is the damping? Let's try to understand. Suppose a building is there, or any material, let steel scale is there, roller is there, steel roller is there, or a building you can consider, or anything, a tall tree you can consider, whatever. Tall, whose one end is fixed, another end is hinged, sorry, another end is free, and that structure or element is having some kind of ductility. So when you are going to apply the load on the free end, what will be there? Guys, tell me fast. क्या होगा? What will happen? एक कैंटिलीवर बिल्डिंग ले लीजिए, ट्री ले लीजिए, डिफ्लेक्शन नहीं होगा. डिफ्लेक्शन तो होगा, बट deflection means what? Deflection is, suppose this is my cantilever. Let's take an example of tree. Okay, coconut tree you can consider. If you are going to apply the load here, so it is going to deflect in this direction, obviously you are correct, but it will stop it here. It is trying to oscillate. It is trying to what? Oscillate back and forth. Okay, forward, backward, what will be there? Oscillation will be there. Am I right or wrong? And that is defining what? Time period, fundamental time period, frequency, what all that things you will get with this coconut tree also when you are going to apply the load over this. But guys, one question I would like to ask: for long life, this will be in oscillation mode, in movement for long life, or after a time it is going to attain its static condition? Yes or no? It is going to attain its static condition after a certain time period. After a certain time period, it is going to attain its static condition. So guys, when you are going to apply the load over this structure, what will happen? It is going to store the energy. Whatever the impact you are going to create there, that is entirely going to be stored by your structure. And by this movement it is going to dissipate that energy. जो एनर्जी स्टोर होता है मूवमेंट के साथ, वो क्या होता है? एनर्जी डिसिपेट होता है. सो इनिशियली यू विल फाइंड दैट दिस इज गोइंग टू ऑसिलेट इन दिस वे. After a few seconds, the movement will remain up to this much. Then after that the movement is going to become this much, and finally it is coming to its a static condition. I got this. That is nothing but the energy dissipation, and that energy dissipation is nothing but your damping property. Got it? That is nothing but your damping property. Damping is nothing but the energy dissipation. जो आप एक्साइटमेंट कर रहे हो, एक्साइट कर रहे हो स्ट्रक्चर को बाय एनी एक्सटर्नल फोर्स, so your structure initially going to respond to that load by its movement, by its oscillation, by its rotation, by its vibration. Let's take about vibration. जब आप impact create करते हो, so वहां पर vibration होता है, but after some time that vibration is going to calm, that vibration is going to stopped, and your structure is coming to its static condition. So what is going to be happen there? Tell me fast. For that period, energy dissipation will be there, and that structure is having what? Having the damping property. So every structure will have some damping property or not? Tell me. हर स्ट्रक्चर में आपको डैम्पिंग प्रॉपर्टी मिलेगा, हर स्ट्रक्चर में डैम्पिंग प्रॉपर्टी मिलेगा. एवरी स्ट्रक्चर वी कैन कंसिडर डैम्पिंग प्रॉपर्टी. डैम्पिंग रहेगा उसमें. सो व्हाट एवर द इम्पैक्ट यू आर गोइंग टू क्रिएट ओवर देयर, सो वो इसको क्या करता है? एब्सॉर्ब कर लेता है, और जब एब्सॉर्ब करने के बाद फिर उसको रिलीज करता है एंड कमिंग बैक टू इट्स स्टैटिक कंडीशन. सो ये मूवमेंट जो धीरे 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 आपका कम हो रहा है, दैट इज नथिंग बट द रिलैक्सिंग द एनर्जी, डिसिपेशन ऑफ द एनर्जी, एंड दैट इज नथिंग बट द डैम्पिंग. उसको बिहेवियर को, वो कॉन्सेप्ट को हम लोग डैम्पिंग करते हैं, प्रॉपर्टी को डैम्पिंग प्रॉपर्टी कहेंगे. सो दिस डैम्पिंग प्रॉपर्टी यू विल आल्सो गेट फ्रॉम योर मोडल एनालिसिस. आपको मोडल एनालिसिस से पता चलेगा कि स्ट्रक्चर का डैम्पिंग प्रॉपर्टी कितना है. Okay, so this is all about your modal analysis. So by modal analysis you will come to know what is the fundamental time period, what is the frequency, by what speed is going to vibrate after the application of the load of particular intensity, and third, you will come to know that damping property, what energy dissipation capability of your structure is, that is the damping property. And guys, the most important thing, the structural integrity. But you will not find anywhere structural integrity, you will find modal mass participation ratio. क्या मिलेगा आपको वर्ड? modal mass participation ratio. modal mass participation ratio. This is the term defining the integrity of your structure. whether your entire structure is taking a part of resisting the load or not in a dynamic response of structure. आप क्या चाहेंगे, पूरा बिल्डिंग एक साथ रिस्पॉन्स करना चाहिए कि नहीं चाहिए, बाइट से इंटायर वेट, या फिर ऊपर का थोड़ा पार्ट रिस्पॉन्ड करना चाहिए, नीचे का क्या चाहिए आपको बताइए फास्ट. होल स्ट्रक्चर शुड टेक ए पार्ट, ऑल्दो इट इज गोइंग टू फेल, ठीक है फेल भी हो जाएगा चलेगा, लेकिन पूरा स्ट्रक्चर लेना चाहिए पार्ट. ओके, सो नॉर्मली इफ यू आर गोइंग टू सी द बिल्डिंग फेल्यूर अंडर द सिस्मिक इवेंट. सो सिस्मिक इवेंट में क्या होता है, बहुत जगह अभी आप देखेंगे सॉफ्ट स्टोरी कॉन्सेप्ट, इट माइट बी इन योर नॉलेज. ओके, इट इज वेरी क्लोज टू द कॉन्सेप्ट ऑफ modal mass participation, otherwise they are slightly different. Okay, but in that soft story concept, the failure will be what, lower floor of the structure is less stiff and upper floor is more stiff. There is a concept of stiffness, there is a concept of what, stiffness. तो नीचे का फ्लोर क्या होता है, कम स्टिफ होता है, ऊपर का फ्लोर ज्यादा स्टिफ होता है. तो बिल्डिंग ऊपर का एज इट इज होता है, नीचे का कॉलम फेल हो जाता है. That is the concept of the soft story. Likewise, in the modal mass participation concept will be what, if your entire structure, entire weight of the structure is not taking a part of resisting the load, what will happen, unequal failure possibility will be there. So that is called as what, modal mass participation ratio. This is one another important parameter we are getting from your Modal analysis. Modal analysis से हम लोग को ये पैरामीटर भी मिलता है. तो टाइम पीरियड मिलता है, फ्रीक्वेंसी मिलता है, आपको डैम्पिंग कैपेसिटी मिल जाता है, मोडल मास पार्टिसिपेशन रेशियो मिल जाता है. ये सारी चीजें आपको मिलेगी मोडल एनालिसिस से, अदरवाइज देयर इज नो अदर मेथड यू विल गेट दिस all things. So tell me, to understand the behavior of the structure without of these properties, can you identify that? Yes, ये प्रॉपर्टी तो आपको चाहिए. Okay, so now coming back to notes, and let's try to understand again these all things with definition. So Modal analysis is the method of structural engineering to find out the structure can vibrate and at what speed, frequency. Okay, Modal analysis is the method to find out the structural response, how it is going to vibrate and to what frequency, क्या frequency से vibrate कर रहा है वो हम लोगों को पता करना है. When there is no external damping. Okay, external damping means there's no any external damper. Okay, very interesting thing, when you are going to see very tall structure, very tall structure, so in that case, in case of the tall structure, your structure is going to deflect to a greater extent. बहुत ज्यादा डिस्प्लेसमेंट हो रहा है, that is beyond of the limit, beyond of the allowed limit, limiting displacement, वाइब्रेशन बहुत ज्यादा हो रहा है, दैट इज अगेन बियॉन्ड ऑफ योर लिमिट, फ्रीक्वेंसी बहुत ज्यादा है, फंडामेंटल टाइम पीरियड बहुत ज्यादा है. सो टू कंट्रोल दैट वी आर गोइंग टू पुट एक्सटर्नल डैम्पर on the top of your building. So what will happen, when your building is going to move in this direction, your damper is going to move in this direction to balance the response of your structure. This is called as external damper or additional damper arrangement we are going to set on your structure. You can Google it, you can search it about it, search about this. So many types of the dampers for the tall structure it is needed to use when the response of your structure beyond the beyond the certain limit of the control, जिसको हम स्ट्रक्चर की कॉन्फ़िगरेशन से उसको कंट्रोल नहीं कर सकते हैं, फिर हम लोग वहां पर एक्सटर्नल डैम्पर यूज करते हैं. तो यहाँ पर वही वर्डिंग यूज हुआ है, मोडल एनालिसिस मेथड स्ट्रक्चर एनालिसिस टू फाइंड आउट द structure can vibrate and at what speed, at what time period it will naturally vibrate when there is no external damper. Means it has to come in its static condition with its own damping property. उसको क्या करना है, खुद की डैम्पिंग प्रॉपर्टी से ही स्टैटिक कंडीशन में आना है, कोई एक्सटर्नल डैम्पर नहीं है वहां पर. ओके, हर स्ट्रक्चर में नहीं मिलेगा ये, इट इज वेरी costly, very expensive practice. Okay, in a very iconic structure, in a very tall structure, very important structure, there we are implementing the concept of the external damper. Okay, so it is not the easy practice. Okay, so नॉर्मली हर स्ट्रक्चर में मीन्स उसकी खुद की डैम्पिंग प्रॉपर्टी को ही यूटिलाइज करेंगे हम. So your structure should come in static condition with its own damping property. Okay, so what, when the structure vibrates freely it moves in a certain fixed pattern. So जब आप एक इंटेंसिटी लगा रहे हो, मैंने फर्स्ट एग्जांपल लिया, first example, the example of your classroom where the teacher is there, where the student is there. A student is going to do some mistake, so teacher is going to what, explain his mistake, is trying to explain his mistake so that he should not repeat it. But when he is again not going to understand, he is going to shout on him. So the type of the loading, type of the impact, first time is trying to explain, second time is going to shout on him. So in both of the action, what is the response of your student? So we are going to capture that response. That is nothing but your shape, mode shape. उसको क्या कहेंगे हम लोग? यस, आपने इंपैक्ट क्रिएट किया, लोड लगाया, स्ट्रक्चर मूवमेंट कर रहा है, दैट मूवमेंट यू आर गोइंग टू कैप्चर. उसकी मूवमेंट को हम क्या कहेंगे? व्हाट वी आर गोइंग टू कॉल इट? यस, यू आर नॉट रिस्पॉन्डिंग गाइस. हेलो, हरी अप. मोड शेप्स, उसको हम लोग क्या कहते हैं? मोड शेप. हर एक एक्साइटमेंट में आपका कैसा रिस्पॉन्स है स्ट्रक्चर का, उसको हम लोग मोड शेप कहते हैं. और मोड शेप, अब वो एक मोड शेप में आपको उसकी सारी प्रॉपर्टी, टाइम पीरियड, फ्रीक्वेंसी, structural integrity means modal mass participation, and then energy dissipation, damping properties, everything you will get in that first mode. Then I am going to change my action. I am going to change my action. I am going to increase the intensity. I will uh, create the impact, or in some other angle I am going to put the load. Then I am going to capture the response of structure. That is will become the second mode. In second mode again you will get the same property, fundamental time period, frequency, modal mass participation ratio. You will get damping properties, everything you will get in that. Then I am going to change the angle of loading, intensity of the loading, action of the loading. Then again I am going to see, again I am going to capture the response of the structure. That is nothing but your third mode. Likewise, will be there any limit for the mode shapes? Tell me. और action of the loading, बताइए, कोई लिमिट हो सकता है क्या? There is no limit. आप एंगल चेंज करो, लोडिंग चेंज करो, मेथड ऑफ एक्शन करो, अनलिमिटेड. So you can have the response of structure in each action, and that capturing the response is nothing but your mode shapes. उसका रिस्पॉन्स हम लोग कैप्चर कर रहे हैं कि बिल्डिंग कैसा रिस्पॉन्ड कर रहा है. So that is but your modal analysis. So natural frequency, how many times per second, it is a very basic thing, you know very well. Mode shape, the shape or pattern of the movement the structure takes on that particular frequency. जो आप एक्शन कर रहे हो उसके अंडर में कैसा रिस्पॉन्स कर रहे हैं उसको हम लोग कैप्चर कर रहे हैं. दैट इज नथिंग बट योर मोड शेप. सो टेक एन एग्जांपल ऑफ योर स्टील रोलर. You are going to apply the load over that external force, and that you are going to remove. Okay, it is just excitement. Due to that excitement your steel roller is going to vibrate, it is going to oscillate, and this will be your response. And you can capture multiple of you can take a multiple of pictures from here, and finding the time period, frequency, and all the dynamic properties from here. So that is what first action. Now you are going to apply the load at the middle. Positioning you can change. Now I am going to keep the same intensity of the loading, but positioning I am going to change. So see the response of my building, my structure, कैसा response हो गया. So this is again the mode shape. This is the mode shape. इसमें से एक कैप्चर कर लेता हूं मैं. पहला मैंने कैप्चर कर लिया. That is what first mode. इसमें से मैंने एक कैप्चर कर लिया. This is the response, second mode. Then if I am going to apply the load by this angle, इस एंगल से मैं लोडिंग लगा रहा हूं, so फिर अलग शेप हो जाएगा कुछ भी. That I am going to capture, that is another mode shape. So multiple mode shapes you can create, and multiple method of deformation you can find for the structure but the action you have to change. Is that all clear or not, guys? Very simple. What is the modal analysis? Now coming back, what is the modal mass participation? Why I am giving the importance to the modal mass participation? Because it is very important. We have to correct the modal analysis based on the modal mass participation. आपको कितने मोड, अभी मैंने कहा कि अनलिमिटेड, अनलिमिटेड, you are also saying that same thing. The modal mode shapes will be unlimited, action of the loading will be unlimited, response will be unlimited, but we have to set some limit. हम लोगों को तो कुछ लिमिट तक के ही काम करना है. So how you will come to know how many number of maximum capturing to do. Maximum capturing means maximum number of modes you should have to consider. कितने नंबर कंसिडर करना है आपको. तो सारी चीजें हम लोग कोड के अकॉर्डिंग्स भी देखेंगे, बट आई एम ट्राइंग टू एक्सप्लेन हियर. सो व्हाट मैक्सिमम नंबर ऑफ मोड्स टू बी कंसिडर, कितने मैक्सिमम कंसिडर करना है. ओके, दैट इज गोइंग टू डिफाइन बाय योर modal mass participation. modal mass participation ये आपको बताएगा कि आपको कितने नंबर ऑफ मोड्स को कंसिडर करना है. सो वेरी सिंपल, आपको पहले ही मैंने एक्सप्लेन किया हुआ है. व्हाट डज विद modal mass participation? modal mass participation ratio. It is what? Ratio. Total mass of the building, total weight of the building divided by mass moving in that particular mode, means mass of the building or mass of the structure taking a part of resisting that applied load. जो आपने लोड अप्लाई किया हुआ है, बिल्डिंग का कितना वेट उसमें पार्ट ले रहा है, आपके बिल्डिंग का कितना वेट उसका पार्ट ले रहा है. सो आइडियल कंडीशन इज व्हाट? आइडियल कंडीशन इज व्हाट? टेल मी फास्ट. व्हाट इज द आइडियल कंडीशन? आपने जो लोड लगाया, आप क्या चाहेंगे? 100% वेट, 100% बिल्डिंग को पार्ट लेना चाहिए. A team is there of 11 fielders, so every fielder should have to take a part. Then there will be chances of the winning. Okay, only 5 players are taking the responsibility for doing everything, so will be there chance of winning? Yes or no? Less chances of winning will be there. So what to do? We have to, we actually want by the ideal condition, and if you are succeeded to get it, that's a good thing. So what we want 100% of the weight, or this 100% structure should take part of resisting the load. So यहाँ पर क्या है, in that particular mode, एक मोड में आपका mass moving in that particular mode should be what? What mass consideration is there that you need to consider in a denominator. In numerator we'll have the 100% mass. If you are going to see this ratio, by multiplying the 100 you will get the percentage of mass participation. कितना परसेंट उस पर्टिकुलर मोड में, मोड 1 में, मोड 2 में. अभी जैसे फर्स्ट मोड में मैंने हिट किया, when I am going to hit on this steel roller, so what is happening? My structure, my steel roller is going to vibrate. So whether it is integrally going to respond this load or not, कि ऐसा तो नहीं हो रहा है यहाँ पर. See, this is what, this part is in this form, and from here it is starting vibrating. Tell me, ऐसा हुआ क्या, या फिर आपको नीचे से पूरा दिख रहा है? टेल मी फास्ट. So here what is happening? 50% height of the building, or suppose it is totally 10 floor for an example. So 5 floor weight is not taking a part. Only above 5 floor is taking a part. Mass of the above 5 floor is taking the responsibility for resisting the load. It is storing the energy. It is releasing the energy. That is going to be done in this upper part only. For the lower part, there is no any kind of stress. They are not going to take any kind of responsibility. That is the mass participation. आपका बिल्डिंग कितना बिल्डिंग बाय इट इज गोइंग टू आइडेंटिफाई बाय वेट, बाय मास. तो बिल्डिंग का कितना मास रोल प्ले कर रहा है, ये हमें पता करना है. एंड दैट यू विल गेट फ्रॉम modal mass participation ratio. ये हम लोगों को ETABS सॉफ्टवेयर में modal एनालिसिस करने के बाद मिलेगा ये रिजल्ट. एंड मेजर डिस्कशन विल बी टुवर्ड्स द modal एनालिसिस, सॉरी modal mass participation ratio. ज्यादा इंपॉर्टेंस हम लोग इसी को देते हैं. ओके, सो mass participation in that
सर
particular mode and total mass. Just a minute. By multiplying by 100, you will get the mass participation. Yes, please.
सर ये जो दिया हुआ है,
Yes.
ये मास मार्टिशियस का जो फॉर्मूला दिए हैं सर, उसको थोड़ा दिखाइए तो सर।
Just a minute. Yeah, have a look over it.
इसमें लिखा है टोटल बिल्डिंग मास डिवाइडेड बाय मास मूविंग इन ith मोड, है ना?
Ith mode.
ये
Yes.
रिवर्स होगा क्या सर? ये ऊपर में टोटल बिल्डिंग मास
Oh,
रहेगा,
sorry.
ये तो उल्टा
Yeah, yeah,
लिखा हुआ
yeah.
है।
No, no. Yes, yes. Sorry, 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 sorry. It's correct. Mass will be total mass will be in denominator. Okay, okay, okay. You are correct. You are correct. I need to put it somewhere else. Okay, take it here. You are correct. By mistake, I take it here. Total mass will be in denominator, and that will obviously be less than of 1 or maximum to equal to 1. Now it's clear. Thanks for correction. Okay, so example here also I have given. Okay, so it is similar to the example of your pillars. Okay, so imagine you have the team of 10 people representing the building mass. First mode, 7 people move, means taking a responsibility, 70% mass participation. Second mode, uh, second 2 people move, 20%. And third mode, 1 people move or taking the responsibility, 10%. And adding, when you are going to add these 3 modes, then will become what? 100% mass participation. So in seismic analysis we had to include enough modes, we had to conclude. So one mode will not enough. Abhi bataiye, just tell me, only one mode will be enough to identify the entire structure response? Abhi bataiye. One time I'm going to excite and I'm going to look at the response of the building, but just one view, okay, will be enough to identify the entire dynamic property of the structure? No, we have to capture the multiple modes. मुझे बहुत सारे एंगल से देखना पड़ेगा, मुझे बहुत सारे एंगल से बिल्डिंग का रिस्पॉन्स को देखना पड़ेगा. Then I will what um, do the composition of all these response, and then I will come to a final solution. What is the worst situation, what is the light situation, what is the intermediate situation? I will compile all those situations and then come to a final solution. So in that same way, in case of modal analysis, we have to consider multiple modes, and we have to consider the multiple modes up to a level till the addition of the all considered modes is not become at least of 90% मास पार्टिसिपेशन. कब तक के कंसिडर करना है? जब तक के 90% मास पार्टिसिपेशन समेशन ना हो जाए. Cumulative modal mass participation should be what? 90% at least. And this is the recommendation when made by your code IS 1893 2016. All these things we will see in reference of code also. Don't worry, सब मैं code से भी आपको बताऊंगा. So here is what? Modal mass participation. Got it? Completely about the modal mass participation. Okay, so this is all about the modal mass participation, nothing more than of this. It's very simple, but it is to understand. जब तक कि आप understand नहीं करेंगे, it will be sound difficult. Okay, so it's very simple. Modal mass participation ratio to find out through this modal analysis, and how to implement in the ETABS software. That's very simple, nothing to do. Where you need to go to ETABS, is a few second task to define the modal to define the modal analysis. Go to define, go to the load cases. It is actually by default present here, even not needed to define. आपको define करने की भी जरूरत नहीं है. It is already present here. Go to modify this, but one change we need to do, that is what? Instead of eigen we should have to use the reads, because it is giving the more accurate result in comparison of eigen one. So I would like to choose that RIS method. Now, here I need to add what load pattern, that will be acceleration in x direction and target dynamic participation ratio. We are targeting to a 99% mass participation ratio. Yes or no? कितना कंसिडर करना है हम लोगों को 99. Okay, if you are getting 100%, so what problem? Code is saying that what you should have to consider the minimum of 90. कम से कम 90% तो मास पार्टिसिपेशन होना चाहिए लोड को रेजिस्ट करने में. So no, code is saying the minimum limit. If you are getting 100%, will be there any problem? अगर आपको किसी स्ट्रक्चर में 100% मास पार्टिसिपेशन मिल रहा है तो इट्स अ गुड थिंग और बैड थिंग? दैट्स अ गुड थिंग. ओके, दैट इज द आइडियल कंडीशन. वही तो हम लोग चाहते हैं. So it is 99%. Okay, now for the x direction I would like to add one more. For the acceleration, for the y direction, again 99%, right, for x and y direction. And now maximum number of modes. So can you tell me now, by this explanation you can say that, can we identify what number of modes will be sufficient at this stage? पता कर सकते हो आप? नो, एट दिस स्टेज वी कैन नॉट आइडेंटिफाई. अभी अब तक हम लोगों ने रिस्पॉन्स देखा ही नहीं है. सो इट डिपेंड्स ऑन द मास पार्टिसिपेशन. अभी मोड्स विल बी इनफाइनाइट. आप कितने भी मोड्स ले सकते हो, बट दैट वी आर नॉट गोइंग टू डू. हम लोगों को तो उस लेवल पर स्टडी नहीं करना है. वी हैव टू लिमिट, बट दैट लिमिट विल बी लिमिटेड टू व्हाट? मास पार्टिसिपेशन. सो वी विल परफॉर्म द एनालिसिस बाय सम इनिशियल नंबर ऑफ मोड्स. हम क्या करेंगे? इनिशियल नंबर ऑफ मोड्स यहाँ पर चूज कर लेंगे. देन वी आर गोइंग टू लुक एट योर रिजल्ट्स. एनालिसिस करने के बाद हम लोग देखेंगे व्हाट इज द मास पार्टिसिपेशन, व्हाट इज द मास पार्टिसिपेशन, व्हाट इज द मास पार्टिसिपेशन. व्हेन वी विल गेट our mass participation as satisfactory up to the 90, 95, 90, 98, 100%, then that is our end. So us time the respective number of modes we are going to finalize. So as of now I am going to take it as what? So it is not any fixed thing. Some of the consultants are asking that to consider equal to number of floors. Some of consultants are saying that 3 times degree of freedoms, 3 times degree of freedoms. So there are different consideration, but it is not a fixed thing. So I am going to consider here as what? Number of modes as, let's say, uh, equal to, let's say, number of floors. So 26. Got it? You will say that no sir, I will take 20 only. You will say that no sir, I will take 30 only.
Sir,
Yes.
this is number of stories or 6 into 3, whichever is more. We should take that, na sir?
नहीं नहीं, एक्चुअली ये मैटर ही नहीं करता है. यू कैन टेक 1, यू कैन टेक 100. गेटिंग?
जी.
तो उसका कोई मैटर नहीं. मैंने कहा ना.
और दूसरा चीज सर, ये जो हम लोग यूएक्स यूआई यूआई की जेड को देने से क्या प्रॉब्लम है इसमें?
That is for z direction. I will let you know why we are
सर.
not considering for the z direction. Okay.
ओके ओके सर.
Yes. So अभी यहाँ पर नंबर ऑफ मैक्सिमम मोड्स तो मैं ले लेता हूँ अभी रफली एट 26. इसको बाद में हमको करेक्ट करना पड़ेगा. ओके, दिस इज नॉट द फाइनल वन. इसको कम ज्यादा हम लोग बाद में करेंगे. दिस आर प्रिलिमिनरी. These are few things are what? Preliminary. First this one, and on means last day we have I think defined.
सर इसको थोड़ा
Wait,
बैक करिए तो उसी को.
just a minute, just a minute. Response spectrum function. When you are going to see the response spectrum function, go to modify this. Sorry. Okay. Dynamic analysis we have defined in our last session. So analyze set load cases to run. Here response spectrum. When you are going to modify this response spectrum, what is happening? Go define cases. Yeah, in these load cases only, dynamic one, modal analysis. So here scale factor, this is also not right one. ये भी wrong है. इसको भी हम लोग आगे जाके करेक्ट करना पड़ेगा. बट दिस ऑल करेक्शन यू विल फाइंड आफ्टर द एनालिसिस. एनालिसिस करने के बाद हम लोगों को इसकी करेक्ट वैल्यू मिलेगी. सो नंबर ऑफ मोड्स you have to correct after the analysis. Scale factor you have to correct after the analysis. एनालिसिस के बाद हम लोग इसको करेक्ट करना पड़ेगा. ओके, सो रिमेंबर दिस थिंग. नाउ टेल मी व्हाट यू आर आस्किंग. हु इज देयर?
उसी को बैक करिए जो दिखा रहे थे अभी.
मोडल एनालिसिस.
हाँ 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 सर,
Okay, just
लोअर
a minute.
केसेस में मोडल एनालिसिस को
Modal
ऑन.
analysis. Okay, tell me fast for
जी
this.
जी जी जी. इसमें जो सर है पी डेल्टा एंड नॉन लीनियर स्टिफनेस, राइट.
Hmm. Hmm. Hmm.
यहाँ पे यूज प्रीसेट पी डेल्टा सेटिंग है,
Hmm. Hmm.
और
Hmm.
नीचे है यूज नॉन लीनियर केस लोअर सेट एंड केस नॉट इंक्लूडेड.
Okay. Okay.
अच्छा
Okay.
अच्छा. तो ये नीचे वाला नॉन लीनियर केस के लिए होगा, ऊपर वाला लीनियर केस के लिए है सर.
P delta analysis. अभी मैं just next to this modal analysis. Our next point is what? P delta analysis.
ओके
Okay,
सर,
we will
थैंक
come to this
यू. ओके
point.
ओके
Yes.
ओके ओके.
Yeah. So yeah, come to your ETABS and let's say okay, modal analysis, and then say okay, done. So, is there any hard and tough step to define the modal analysis? No, nothing is hard and tough. Very simple, just a task of few seconds. But the concept is important. Unless you are not understanding the concept, no use of the software. Getting my point? That's why I have explained everything. Now, next point, that is to
सर
understand
थोड़ा
about
सा
the
रीच और एजेंट का डिफरेंस थोड़ा बता दीजिएगा सर, कभी टाइम मिलेगा तो.
that. Yes, yes, yes.
जी.
Okay. Now, second point is your P delta analysis. Okay, so when you are going to see your IS 16700, where it is? IS 16700. Yes, have a look over this. IS 6700, the code for your tall structure is intentionally asking to consider the P delta if P delta effect for your structure. Few of the important things were intentionally where the IS 16700 is asking to consider for your structure when you are going to deal for the tall structure and when you are going to consider your lateral load. So, flow diaphragm concept, cracked section property. This part also we'll discuss in upcoming session. Okay, so crack property, flow diaphragm concept. So these all things we are considering. But see, P delta effect. It is asking to consider it anyhow when you are going to structure, when your structure is subjected to lateral load and when it is tall structure. Okay, earthquake load is there. Okay, so, what is the P delta effect? What is the P delta analysis? Let's try to understand. So, it is nothing new. We already considering the P delta. We already considering the P delta in every structure. But we are considering the first order P delta effect on your structure. You are going to consider the displacement of your structure. Are you considering or not? In any of the structure, whether the deflections are within limit or not. Due to that uh, uh, stresses, we are going to design our structure. So that is the first order of P delta. First order of deflection, first order of P delta effect we are going to consider when there is a structure. Have a look over this. When there is a structure and if you are going to apply the load over this structure as lateral load and there is a what gravitational load, so what is going to be happen due to this lateral load, maximum stress is going to be formed at its base. Obviously what is happening, this is what the lateral force, this is a perpendicular distance, so the moment will be what, moment will equal to lateral force into perpendicular distance, that is going to become what, moment at the base of your structure for which we are going to design our structure. This is the global effect. This is what, global effect. But if I am going to break it into a floor wise, I am going to break it in a floor wise. Suppose this is my base level, this is the first, second, third, fourth. So what stress is going to be developed at this column base due to the lateral load? We are going to design this column for this movement. We are going to design this column for this movement. This is on the top. So due to this lateral force, this height is going to become, so here movement will be more, here movement will be more, is going to be adding. So this is what we are considering in every structure. What's new in this? So this is the first order analysis, and your P delta effect is your second order analysis. It is a second order analysis. What is that? Let's try to understand. When you are going to consider the undeflected structure, so what we are going to do, lateral force, perpendicular distance, whatever the movement is coming globally, we are going to design for that. Whatever the movement is coming, means by the local section consideration, each individual floor column, we are going to design that. So it is the first order. Now second is what? When you are going to apply the lateral load, when you are going to apply the lateral load, your structure is going to deflect in this pattern. क्या होगा? स्ट्रक्चर आपका डिफ्लेक्ट होगा. ओके, फर्स्ट केस में इज देयर एनी इंपैक्ट ऑफ दिस ग्रेविटेशनल लोड फॉर द फ्लेक्सुरल डिजाइन ऑफ दिस मेंबर? ये मेंबर का फ्लेक्सुरल डिजाइन के लिए देयर विल बी एनी इंपैक्ट ऑफ योर ग्रेविटेशनल लोड? कुछ इंपैक्ट था क्या इसका? No. Why? Because the action of the loading passing through the point of the support. So there is no perpendicular distance. Basic formula, engineering mechanics. What is that? Movement will be equal to force into perpendicular distance. You all know that. आपको perpendicular distance find out करना है. Force है आपके पास, you will get the movement. So here the force is passing through the point of your support. So there is no perpendicular distance. How you will consider this? But this is what? This is the action of the loading. This is the perpendicular distance. That's why movement is going to be formed at its base, and for which we have to design globally, and locally you can design all the elements. Okay, but this is not the end. When you are going to apply the load, your structure is going to be deflected in this form, and your building is what? In this, your building is going to attain this shape. अब बिल्डिंग आपका क्या अटेन कर रहे हैं? ये शेप अटेन कर लिया है. सो योर पॉइंट ऑफ लोडिंग व्हाट? गोइंग टू बी शिफ्टेड फ्रॉम दिस पॉइंट टू दिस पॉइंट. एक्चुअली यहां पर नहीं होगा, ये एक सेंट्रॉइड पॉइंट से कॉन्सेंट्रेट होगा, right? But as of now we are going to consider it is going to be shifted from this point to this point. Now this is the fixity. This is what? Your fixity. Now tell me, uh, in comparison of the first case, in the second case, will be there additional movement to the base of the structure or not, due to this gravitational load? Yes or no? Additional movement आ जाएगा? Yes, that is called as secondary movement. Primary movement will be what? Have a look over this. Very simple. Primary movement 1 will be equal to your lateral force multiplied by your height of the structure. And secondary, okay, this is the movement due to the P force, and the distance will be what? Distance is nothing but this delta. So this is called as P delta. P delta. This movement is going to be added as a movement 2. Movement 1, primary movement. This is called as secondary movement, and this is what? Additional movement is going to be added in this. So when you are going to consider the P delta effect, you have to design for both of the movements. You have to design for what? Both of the movement. And this delta, how you can calculate this delta? By M movement multiplied by L square divided by 3 times modulus of elasticity and moment of inertia, and movement will equal to what? Shear force multiplied by length. So if you are going to put over here, so delta displacement you will get by this formula. डेल्टा आपको किससे मिलेगा? ये फॉर्मूले से मिलेगा. जस्ट फॉर अंडरस्टैंडिंग, हम लोगों को ये कहीं कैलकुलेशन नहीं करना है. डोंट वरी, कहीं पर हमें इसका कैलकुलेशन नहीं करना है. So P delta effect. Now displacement 1 in case of first case, displacement 1, these are displacement 2. Total displacement is going to become this much, delta 1 delta 2. First case, second case, okay, delta 2. And finally we can see that compared to the original deflection value, there is an extra term to the right in terms of P and delta. If P and delta are significant value, the standard linear static analysis would under the estimate the deflection of the column. Okay, so if you are going to consider only the primary effect, okay, primary effect, you are going to underestimate the deflection. You are going to underestimate that stresses in your member. if you are not going to consider the second order effect, the moment caused due to your gravitational load, you are going to consider only the moment due to your lateral load at the base of structure with a primary effect. You are going to underestimate the design of your complete structure or component part of your structure if you are not going to consider the second order effect, that is nothing but your p delta analysis. आपका p delta analysis, okay, this is what p big delta, it is what p big delta means, for which you are going to see the overall structure, global structure. But in reality what is happening, when my floor is going to be deflected, each column is going to be what deflected in this pattern. This is the first floor, second slab, this is one, third maybe of this shape. So deflection will be there. Every floor is attains its own deflected mode. So यहाँ पर भी small deflection आएगा. Actually what, actually this is the orientation, this is what alignment of your column, ये alignment है. But reality में आपका displacement इस तरीके से होगा. रियलिटी में आपका डिस्प्लेसमेंट किस तरीके से होगा, इस तरीके से डिस्प्लेसमेंट होगा. लेट मी शो यू, आई हैव अनदर figure to show for better understanding how the structure will respond. Look at this figure. I think in this also it is not available. Sorry. Yes, have a look over this. See, entire structure is deflected. Okay, so initially the mass is concentrating from the center. Now mass is going to be shifted from its original, so this will be your delta, and each individual column is what, deflected or not, each individual column is deflected or not. Yes, हर एक individual column, हर एक individual beam, it is also flexurally going to respond, it is going to it is going to be deflected. So it is called as what, this is a big delta, p big delta, p small delta. Okay, so for this small delta, this column is going to be designed, and this entire structure is going to be what, means that entire stress is going to be subjected to base of your structure. सारा स्ट्रेस आपके बेस पर ट्रांसफर होगा ग्लोबली, दैट इज व्हाट पी बिग डेल्टा इफेक्ट, and each individual is shifted from its original orientation. So uh, original alignment, okay, actual alignment. So what is going to be happen, additional stress is going to be imposed to each individual member, हर एक member पर additional impose होगा due to this lateral displacement, flexural response due to this displacement p small delta. So actually p delta effect will be equal to what, actual force into big delta plus stresses, means mass of each individual column, means member, local effect. So weight of your member multiplied by small delta. So this is actually the complete p delta effect. But normally we are not focusing to this part in deep, we are just focusing to only the p delta effect. Okay, so your software is taking care about this, सॉफ्टवेयर इसको देखेगा, नो नीड टू वरी अबाउट. बट अभी हम लोग डिस्कशन में सिर्फ पी बिग डेल्टा इफेक्ट को ही कंसिडर करते हैं. क्लियर? सो दिस इज कॉल्ड एज पी डेल्टा इफेक्ट. And guys, this p delta effect results is going to be utilized for the purpose of designing also, for the purpose of serviceability checks also. So p delta effect is not directly going to be considered for the design. This p delta effect results is going to be utilized in many of the different methods, for the serviceability checks methods, for the designing methods, सारी जगह पर हम लोगों को इसका लगेगा. ठीक है? Only if you are going to consider the lateral load without a p delta, you will get the actual displacement, yes or no? p delta को consider करे बगैर आपको actual displacement मिलेगा? No, you will not get that. So p delta you have to consider in a basic uh, uh, analysis for the serviceability checks, For the vibration checks, P delta effect plays an important role. वहां पर भी ऐड होगा. For the case of modal analysis, can you imagine modal analysis without a P delta? Yes or no? No. So modal analysis will not directly going to be utilized the result of modal analysis, but it is going to be utilized via other methods of analysis. उसमें बहुत सारे मेथड्स हैं जहां पर हम लोगों को पी डेल्टा इफेक्ट का रिजल्ट को यूटिलाइज करना पड़ता है. इज दैट ऑल क्लियर अबाउट द पी डेल्टा इफेक्ट? Yes or no? Now, one question I would like to ask, this P delta effect is due to lateral load or is due to gravitational load? किसकी वजह से है ये? Lateral load. Pandian saying that lateral load. Okay. Gravity load. Ashwin saying that gravity load. Okay. Or both is there? Ashwin saying both. Okay. He's changing his answer from gravity. No, guys. You are wrong if you are saying both. You are wrong if you are saying lateral load. It is actually due to only the gravitational load. Gravitational load की वजह से है जी. यहाँ पर have a look over this again. This figure, lateral load, and due to this lateral load, what stresses is coming, that we are going to consider in our basic approach. Yes or no? In the first order analysis, वो तो कंसिडर कर रहे हो आप, वो तो छोड़ते नहीं हम लोग. Whether the P delta effect considering not considering, that doesn't matter. Lateral load is coming. Due to this lateral load, what stresses is coming, we are going to see that. And due to this lateral load, deflection will also be there. That is also we are considering in our first order analysis. But secondary moment is going to be added due to what? Gravitational load only. अभी ग्रेविटेशनल लोड ही नहीं रहेगा तो यहां तक के सब पूरा होगा. But will be there any consideration, will be there any effect of your P delta effect? P ही नहीं है तो डेल्टा डेल्टा तो रहेगा. डेल्टा is coming anyway. Delta will be there whether P is there or not, that doesn't matter. Delta will be there, but if P is not there, will be there chance of P delta effect? No. So that is what lateral displacement is caused by your lateral load. So that lateral load effect we are considering in the first order. First order में हम लोग उसको तो ले रहे हैं ना, उसको कहाँ छोड़ते हैं हम. But tell me, if the P value is not there, will be there effect of P delta effect? P delta, tell me. Additional movement आएगा क्या? Secondary movement? No. So your second order analysis is mainly based on your gravitational load, not the lateral load. Please clear this point. यहां तक कि हम लोग फर्स्ट ऑर्डर ऐसे भी करते हैं. आप ऐसा नहीं है कि सिर्फ इतना ही कंसिडर करते हैं हम लोग. डिस्प्लेसमेंट भी होता है हमारे बिल्डिंग का. वी आर ऑल्सो गोइंग टू कंसिडर दिस डिस्प्लेसमेंट. वी आर गोइंग टू डिजाइन इन द मेंबर फॉर द डिस्प्लेसमेंट. We are designing the movement at the base due to this lateral load. Okay, that also we are going to consider. सब करते हैं. What point is going to be added there? Additional movement. That is what? P into delta भी आता है. Displacement होगा means delta is there. If P is not there, will be there additional movement? P is not there, will be there additional movement? No. So guys, there is no any impact of your lateral load. Okay, so again it is a few second step to define the P delta effect or P delta analysis in your structure. Go to define, go to your load sorry, P delta option. Once you click on the P delta option, here none is there. Non-iterative based, it is the iterative based. Check this, it is a repetition. Okay, it is the iterative based. And two options where there is a recommendation. One is what? 1.5 dead load, sorry, 1.2 dead load plus 1.2 live load. This is the first option. And second option is what? 1.5 dead load. Hello. 1.5 dead load or 1.2 dead load plus live load, which one to be consider, कौन सा consider करना चाहिए, क्योंकि both all the gravitational loads, बताइए fast. First one, second one, which one will be the critical one? No guys. Okay, both of these you can consider, means any of these one you can, some of you will say that sir I will consider this, some of you will say that consider this. So कोई सा भी ले सकते हो, no doubt both are correct, but this will give the more critical result. Why? In comparison of your live load, the dead load in your structure is more or not. आपका self weight of the structure, you have assigned the additional dead load, so overall dead load of the structure is more, so the factor, have a look over this, it is 1.5, it will be more critical. You will see that sir here 1.2, 1.2 live load, so live load is very small in comparison of your dead load. In comparison of your dead load, live load is very small. So that's why I would recommend to go with 1.5 times dead load live load. So here dead load you just have to put as 1.5, add it, and that's a okay. हो गया आपका P delta definition. Hello, just a few seconds required to define it. P delta analysis is what defined. I need to go to ETABS and go to define P delta effector, P delta option. Okay, it is not defined, simply say okay, go to define and load cases, and just now we have defined the Modal analysis. Go to modify this. See, Modal analysis is going to use your results of P delta. अब तक के यहाँ पर नो दे रहा था, अब क्या दे रहा है यहाँ पर, इटरेटिव बेस्ड ऑन लोड्स, द डेफिनेशन यू हैव डिफाइंड, आपने जो डेफिनेशन डिफाइन किया है इसके रिजल्ट को फॉलो करेगा Modal एनालिसिस. गॉट इट? Which step, Madhura? Tell me.
Sir, that definition of P delta in ETABS.
Okay,
Just
simple hai. Go to define. Go to
define.
the P delta option.
Okay.
In this, there is an option of none, iterative based, non-iterative based. The iterative based method of analysis. You can read the definition. I will see. I will give the notes. Okay. Yeah. So it is dead 1.5. Some of the consultants are following 1.2 times dead load, live load. Okay. So you can go with that, you can go with this. I am considering the critical one. Okay, I will show you what is the total live load of the structure, total dead load of the structure. You can compare. We will see that. इसका भी हम लोग क्या करेंगे, we will see which one is the critical one. आप directly भी कर सकते हो, otherwise you can do the analysis and come to know what is the total live load of the structure, what is the total dead load of the structure. If 1.2 times dead load plus 1.2 times live load is coming more, you can follow this one. अगर 1.5 dead load ज़्यादा आ रहा है तो आप इसको follow करो. Okay, by that way you can decide. But as of now I am expecting that this dead load with a factor of 1.5 will be more critical as per my experience. That's why I am going to adopt it. We will check it later on. इसको मैं check भी बताऊंगा आपको. Okay, let's say okay, go to define. So what I'm saying that when you are going to see the load cases in the Modal analysis, it is going to follow. As I told you, P delta analysis results is going to be followed by many of the other methods. उसके रिजल्ट को कितना डिफ्लेक्शन आया है उसको फॉलो करता है बहुत सारे मेथड, वाइब्रेशन एनालिसिस, P delta Modal analysis. Okay, many of the serviceability checks were followed the result of your P delta analysis. Okay, so यहाँ पर Modal एनालिसिस भी आप देखेंगे, so that is going to follow the result of your P delta. आपके P delta को follow करेगा ये, right? So let's say okay, let's say okay. So this is all done. I am going to save this file. Clear? Yes, but guys, before of going for the analysis, one part is remaining that is very much important, that is the concept of the property modifier or stiffness modification. Okay, so when you are going to define the section property, define frame, area or shell section. So define all the required beam, column, slab and shear wall. There was one important point, that is nothing but defining the property modification as per IS 16700 2017. So when you are going to see IS 16700, it is asking to consider in your mathematical model. Computer modeling shall consisting of the following things, amongst them p delta analysis, diaphragm concept, all these things we have implemented. One thing was remaining, that is what, cracked section cross sectional area properties as per the table number 6. So table number 6 has recommended that we should have to consider the cracked section. So what does it mean? Let's try to understand in detail. What does the property modifier? Sometime we are calling it to stiffness modifier. Sometime we are calling it to strength modifier. Okay. So these are the name of the same thing. So guys, try to understand. A frame is there. Okay. This is what the frame which is subjected to your gravitational load. A frame is there. Frame means beam, column, everything is there, and the shear wall is also there, and that frame is subjected to your gravitational load. So when your frame is subjected to gravitational load, so the resisting strength of your section will be your concrete, means your concrete, and your reinforcement will be there. Both combinedly going to resist your load. Both combinedly going to resist your load. And as we know that we are designing our section such that that should not pass the limit of the serviceability. Means if you are going to consider the deflection, so for the case of your beam, for the case of your column, for the case of your slab, we are designing all of these elements within their limit of the serviceability. So there will not be a chances of the cracking. Okay, there will be not a chances of your cracking. For the life of the structure, very minor cracks are happening. So there will be chances of the development of the shear cracks. So for that we are going to provide the shear reinforcement for the case of the beam, for the case of the column, for the different element. There is a question of your flexural cracks. इसका क्वेश्चन है, flexural crack का क्वेश्चन है. So as earlier we have discussed that when there is an application of the loading, so the beam is going to be deflected in this pattern. The beam is going to be deflected in this pattern. So when the deflection of the beam is going to be exceeded beyond of its certain limit, so what, there will be formation of minor cracks here. Okay, this is nothing but your flexural cracks, and one crack is going to be developed here. This is the shear crack. So as of now our concern is not your shear crack. As of now our concern is your flexural cracks. So first situation is that we are designing our section such that it should not goes to the uh, is not going to pass the limit of the serviceability, pass the limit of the deflection. So there is no chances of the formation of your flexural cracks. And one thing for the middle portion, one thing for the case of your beam column connection. So at the beam column connection, the heavy stresses are not going to be formed in case when your structure is subjected to gravitational load. यहाँ पर कुछ कॉम्प्लिकेशन नहीं है. यहाँ पर कोई कॉम्प्लिकेशन नहीं है. टाइप्स का आपका फ्लेक्सुरल क्रैक यहाँ पर फॉर्म Write in the chat box. Yes. Am I audible? Why you are not responding? Am I audible? Is my screen is clearly visible to all of you? Okay, fine. So what topic we are discussing? Tell me. What topic we are discussing? Cracked section. Okay. So what was the last point? Anyone? About the normal frame which is subjected to your gravitational loading. Is it right or wrong? Okay. So in this situation, when when there is only gravitational load, when your framing is there and there is a what concrete section along with your reinforcement, so it is a, in this situation you can consider the 100% stiffness, 100% stiffness of your section at any of the point. आप किसी भी point पर 100% stiffness you can consider. What is the stiffness formula? K is equal to square root of EI by A. The formula for finding out the stiffness of the section. Okay. And this is what K is mainly directly proportional to your moment of inertia. Moment of inertia is your BD cube by 12 for the rectangular section. So at any of the section I can consider the 100% stiffness, 100% section properties taking a part of resisting the load throughout the life of the structure. Getting my point? There are different stages of the loading. Loading के भी stages होते हैं. When you are going to build your structure, you are going to put the load over that. उसके ऊपर आप load put करेंगे. You are going to put the load, that is the impact, means action of the loading. Then there will be what sustained load, means the load will be sustained for for the considered life of the structure. And there is another type of the load, that is nothing but your instant load or impact load. That is, we are going to consider your earthquake and seismic event. So these are the impact load we can consider, quick load we can consider. So there are different situations of the loading which is going to act over your structure. So that different situation is not going to be considered for the case of your, for the case of your building which is going to be subjected to only gravitational load. यहाँ पे सिर्फ आपका gravitational load है, complicated load यहाँ पर नहीं है. तो यहाँ पर flexural cracks के chances कम है. So that what we can do, we can find out the stresses, we can assume the full strength of the section throughout the life of the structure. पूरी life में under the serviceability case, under the factored case, we can consider that our full section with its full strength is ready to resist your load. जो भी आपका लोड आ रहा है उसको रेजिस्ट करने के लिए पूरा सेक्शन फुल स्टेबिलिटी के साथ अवेलेबल है फॉर रेजिस्टिंग द लोड. गेटिंग माय पॉइंट? Getting my point? That is nothing but your uncracked condition. That is nothing but what? Your uncracked condition. Okay. So in your definition in these notes, I have given the uncracked moment of inertia. As I told you, there is a discussion of stiffness, but stiffness is mainly directly proportional to your moment of inertia. Moment of inertia, that's why हम लोग इसको moment of inertia से consider करेंगे. So moment of inertia for the case of uncracked, okay, for the case of uncracked condition, 100% properties we have to consider in the definition. 100%, there is no any deduction. But guys, the problem is going to arise when your structure is going to be subjected to seismic loading. जब आपका seismic load आ जाता है and when the heavy wind flow is there across your structure, at that time the problems of the cracking, that is nothing but your flexural cracks are arising. वहां पर flexural cracks आएंगे. There will be possibility of the flexural cracks and there will be formation of high stress zones. There will be a formation of what? High stress zones during the seismic event, during the your heavy wind flow. At that time, uh, high uh, high stress zones are going to be formed, and that high stress zones will be your beam and column connection, will be your beam and column connection at every of the points, beam and shear wall connection at every of the points. This is what we are expecting, or this is what the scenario most of the time have been seen, but it is unpredictable. The high stresses may also be formed at this point, high stresses may be formed at this point, because reversal movement will be there, reversal action will be there. Let me show you, either the figure is available or not, I don't know. Reversal movement, okay. Where it is available, yeah, I think here. Let me show you. Have a look over this. When your building is subjected to only the gravitational load, so stress distribution will be what? A flexural response of the building will be what? At this point sagging moment, at this point hogging moment, at this point hogging moment, one moment is there. But guys, when you are going to consider the flexural response under the lateral load case, for the sway to the right direction, in this way, here the sagging, here is the hogging. In a short period of time, it is changing its direction to left side. Now here it was sagging, it was, now it is becoming as hogging. Here it was sagging, it is going to become hogging. So it is very, in a few seconds, this complete process of right sway, left sway, sagging and hogging, it is going to change. So actual pattern will be of this shape. एक ही पॉइंट पर आपका सैगिंग भी आ रहा है, एक ही पॉइंट पर हॉगिंग भी आ रहा है. नाउ हैव अ लुक इन कंपैरिजन द मिडल पार्ट दैट इज फाउंड टू बी न्यूट्रल. Here you will find what? At the same point, sagging hogging for the column, for the beam. So it is a high stress zone. This is what? High stress zone. Is it possible to understand or not by the figure? Tell me guys. This is the high stress zone, and guys, that will leads to the formation of the cracks in your section, for the beam, for the column, or for the shear wall, or for the slab also. Whatever the element is there, in all the elements we cannot expect what kind of cracks are going to be formed. So here you can understand that at the middle part is neutral, at the middle part is what? Neutral. But at the end section, high stresses are there. So what is happening here? The major cracks are going to be formed here, the minor cracks may be formed, or no cracks will be there at some of the points along the span of the beam. Same is happening for the case of your column. Same is happening for the case of your column. So I have shown this thing in this figure. यहाँ पे मैंने इसको proper present करने की कोशिश की है. यहाँ पर देखिए, it is what? High stress zone, column and beam connection. You can consider the shear wall also. Okay, shear wall and column both can be considered same. So यहाँ पर देखिए क्रैक्स फॉर्मेशन हो रहा है, यहाँ पर क्रैक्स फॉर्मेशन हो रहा है, यहाँ पर क्रैक्स फॉर्मेशन हो रहा है, यहाँ पर माइनर क्रैक्स फॉर्मेशन हो रहा है, यहाँ पर मिडल में हो रहा है, यहाँ पर इधर हो रहा है किनारे. So can you consider any specific location or specific form of the cracks? Can you ensure that for the during the seismic event? हम लोग इंश्योर कर सकते हैं क्या? No, we cannot ensure. Now in that situation, if I'm asking you to consider the stiffness of this building, आपको इसका stiffness consider करना है, not entire building. I'm asking for this beam, I'm asking for this beam, I'm asking for this beam. So stiffness, try to understand, stiffness is nothing but the rigidity. Stiffness is resistance to your deformation. Means it is the one kind of your strength, capacity. So what is that? K is directly proportional to your moment of inertia at any of the section. What formula you will use the moment of inertia? BD cube by 12. This is the formula to calculate the moment of inertia. If you are able to use this formula confidently, so you can say that full gross moment of inertia will be what? BD cube by 12. This is your gross moment of inertia. But guys, if I'm asking to find out the moment of inertia at this point for the case of your beam, so there is a formation of the crack है वहां पर, तो आप ये फॉर्मूला यूज कर सकते हो क्या? बी डी क्यूब बाय 12. Can you use this formula? No, you cannot use this formula because your section has lost its integrity. उसकी स्ट्रेंथ रिड्यूस हो गई है. स्टिफनेस इज मींस बॉन्डिंग, मींस ये सॉलिड सेक्शन था. जस्ट फॉर अंडरस्टैंडिंग आई एम यूजिंग दिस वर्ड्स. ओके, it is the bond, means proper bonding. Entire section is what? Acting as with full of integrity. पूरे इंटीग्रिटी के साथ, पूरी स्ट्रेंथ के साथ सेक्शन है. सो हियर यू कैन कंसिडर द फुल ग्रॉस मोमेंट ऑफ इनर्शिया बी डी क्यूब बाय 12. बट इफ आई एम गिविंग a micro level very minor crack, if suppose I am going to provide here very minor crack, so complete strength is lost or not? पूरी स्ट्रेंथ उसकी लॉस हो गई कि नहीं? यस, that is one kind of fracture. Abhi, your hand is there, if suppose going to become if suppose there is a what, a macro crack is a very minor crack is there, so can you perform in the same way as that you are performing with your hand without of the crack? फर्क पड़ेगा ना? That is the same thing with your section. Even though it is a very minor crack, but still it is going to lose its entire strength. उसकी strength वो नहीं रहेगी जो as a full integrity के साथ उसकी strength थी. So that is nothing but your cracked section. So guys, what is happening if I am asking you to find out the uh, stiffness of the beam element, or if I'm asking to consider one stiffness for this complete beam, so that will be wrong. Or if suppose you are going to consider one stiffness for this one beam, that will be wrong. पूरा full strength अगर आप इसको consider कर रहे हो, wrong है. Because in reality you will not get it. When your seismic event is happening, so initially your section will have its full of strength. उसकी initially तो रहेगा, लेकिन जब seismic event उसको hit करेगा, so it is going to be what? Cracked. And seismic event is what? Repetitive. For a short period of time it is what? In repetition. So initially your section will have the full of strength for resisting it, but the second time your section is not having the strength to resist it. Getting my point? So in your analysis at every of the point you were consider 100% stiffness. आपने हर stages पर you have considered the 100% stiffness, but in reality what is going to be happen? Your section is going to lose its strength. तो ये डिफरेंस हो जाएगा कि नहीं? बताइए. आपने डिजाइन 100% कंसिडर करके दिया है और वहां पे परफॉर्म सेक्शन कर रहा है विथ इट्स 30% स्ट्रेंथ. सो व्हाट विल हैपन? टेल मी गाइस फास्ट. कुणाल, व्हाट विल हैपन? पांड्यन, अश्विन, मधुरा, क्या होगा? फेल्योर हो जाएगा. There will be what? Collapse. There will be what? Failure. Getting my point? So that is important too. And section will be what? Failed. So that's why what to consider here, guys, we need to consider this reality. So we should have to consider the cracked section. यहाँ पर okay, so you will say that sir at some point we are getting the full strength, full stiffness, somewhere we are getting the cracks. So if suppose you are going to find out the variation, so that will become very difficult. That's why our code is recommending that we should have to consider the reduced stiffness. आपको क्या करना है? Reduced stiffness means cracked section you have to consider. And for the case of service case, for the case of your design, so at the case of the serviceability checks, so it is recommended to consider for the case of slab only 35% of the stiffness to be considered, for the beam 70%, for the case of column 90%, for the case of your wall 90%. so this stiffness is needed to be considered. यहाँ पर हम लोग 10% को इग्नोर कर दे रहे हैं, 10% यहाँ पर भी इग्नोर कर दे रहे हैं फॉर केस ऑफ बीम एंड कॉलम, सॉरी कॉलम एंड वॉल्स. फॉर द केस ऑफ बीम वी आर ignoring 30%, we are considering only the 70%, and for the case of the slab we are releasing the 65% and only considering the 35%. Getting? This is for the service case. But when the ultimate load is there, when you are going to design it, at that time it is recommended to further reduce it, because अब finally हम लोग design कर रहे हैं. This is for the serviceability check, this is for your design check, this is for your design finally. So 25% to be considered, 35% to be considered, 70% to be considered, and 70% to be considered. So guys, at the stage of the serviceability check, deflection check and all kind of checks, we need to perform the, we need to define these uh, moment of inertia. And when you are actually going to design the member finally, you have to consider this moment of inertia. Got it? Yes or no? Yeah. So I need to go to your ETABS, go to define, go to your load, uh, go to your section property, and go to your frame section, beam. Just click over the modify. Once you click over the modify, clear it, go to modify and show rebar. Sorry, this is not modify and show uh, modify and show modifier. In this case, for the moment of inertia, here I have defined it clearly. For the case of slab it is, for the case of beam, okay, for the service cracked 111, for the torsion we are releasing, we are considering secondary torsion. That's why in ETABS it should be defined as for the torsion 0.001, and moment inertia for the beam, for the case of beam 0.7, 0.7 beam, yeah, 0.7, 0.7 for the case of your beam. So go to your ETABS, 0.7, and it should be what, 0.7. That's done. It's simply say okay, say okay. For the second
Torsion point, not one, sir. Point not one.
point, not one, also point one also, both you can take, okay.
Okay, sir.
1%, 0.1%, okay, we are not putting it to zero, okay. That's only 0.7, 0.7, it should be your
So
0.7.
while designing tall structures only we have to do this.
Yes, yes. Modify this. For the case of, for the case of your column, what is torsion will not be there, means okay, releasing for the case of column also we are releasing the torsion 0.01. If suppose you want, or if it is failing, then you can change it, but as of now I'm going to keep it here. अगर फेल होता है तब हम लोग को एक ऑप्शन होता है, but let it to be. For the case of your column, yeah, 0.9, 0.9 for the service case, 0.9, it is what, 0.9. Let's say okay, and say okay, go to this, modify this, modify this, 0.9, 0.9, That's done. Okay, modify this, modify this. It should be 0.9. It should be what, 0.9. That's done. Okay, okay. Then go to, say okay, go to define, go to section property, go to the slab section, just click on this modify, modifier. Yes, this is the very important, and to understand it we need to understand the concept of in plane stiffness and out of plane stiffness. Have a look at this figure. Okay, understand the concept of what is happening when you are going to see, when you are going to define this property modifier for this beam. So actually what is happening, by defining this property modifier you are making it to free. ये actual में क्या होगा, if, very simple, already we have discussed, if you are going to define one section of 230 by 450 and one section you are going to define as 300, sorry, 300 by uh, 600 you are going to define, or 900 you are going to define. So will this member will take more stress, or will this section will take more strength, more stresses towards it? कौन लेगा ज्यादा? Heavy section will attract more stresses, and that's why we are going to consider it. So here the section we are going to keep it same. मैं यहाँ पर, हम यहाँ पर क्या कर रहे हैं, सेक्शन को सेम रख रहे हैं. We are going to take a 230 by 600 for an example. We are going to keep the section as same. Now we are playing with its property. इसकी property में हम लोग deal कर रहे हैं. अब section को change नहीं कर रहे हैं. We are going to deal with the property of this section. So if I am going to consider 100% area, so 100% area consideration will be there. If I am going to define area as 0.5, अगर मैं यहाँ पर area 0.5 लिख दूं, so actual में section definition तो यही रहेगा, but only the area consideration will be what, 0.5. so automatically ये section size कम हो गई. अब ये actually for an example 115 by 300 instead of we are making that, by changing this we are just defining as 0.5 ratio percent, 0.5. okay, 50% we are going to do the reduction in the area consideration. So while the analysis, एक्चुअल जो प्रॉपर्टी थी उसमें हमने मॉडिफिकेशन कर दिया. सो इन रियलिटी सेक्शन डेफिनेशन इज सेम 230 by 600, but while doing the analysis and designed, finally what area going to be considered, this area is going to be considered. In the same way, what we are going to do, from your actual gross moment of inertia we are going to reduce it by 30%, and we are going to consider only 70% of it. इसका 70% ही हम लोग कंसिडर करने जा रहे हैं. सो व्हाट विल हैपन, इट इज गोइंग टू बिकम फ्री टू कैरी द स्ट्रेसेस. अब ये इतना स्ट्रेस नहीं लेगा. देन what about that stresses, जो 30% स्ट्रेस था वो कहां जाएगा? that 30% स्ट्रेस कहां जाएगा? टेल मी गाइस फास्ट, कहां जाएगा वो 30% स्ट्रेस? that is what distributed to the other element. वो कहां जाएगा वो हमें नहीं पता, but it is going to be distributed some other element, कहीं पर भी तो जाएगा वो. so this is what the distribution of the stresses. इसमें हम लोग रिलैक्स कर रहे हैं the particular element to carry the stresses. so the stress which we are going to like ignore, that is not going to be ignored, it is going to be transferred to some of the other element. वो किसी और को चला जाएगा. getting my point, yes or no? yes. Now have a look over this figure. In plane and out of plane, this is the in plane direction. This is for this plate, it is the in plane. This is the in plane, and along the depth it is out of plane. For the case of your shear wall, this is the in plane direction. This is the in plane direction, means the direction in which the stiffness is more. This length is more, this width is more, means this height of the wall is more, this width or length of the wall is more. and this width is less, so it is the out of plane, and this is your in plane direction. So your shear wall will have the more stiffness, more capacity to carry the stress in this direction. It is having the more stiffness, more capacity to resist the stress in this direction, vertical and this direction. For the case of slab, it is stiff enough in this direction. अगर मैं यहाँ पर load लगाता हूँ lateral, so your slab is having very high stiffness in this direction to resist this. If I am going to apply the load in this direction, so your slab long span is available in this direction. But the same load, if suppose I am going to put in this direction, only this depth is available for resisting this load. So guys, out of plane stiffness is very much small in comparison of your in plane stiffness for the case of your plate element. Now ETABS software is showing the stresses in this x direction as 11 f11 direction 1. It is the f22 stress in plane. For the case of plane, in plane is f, ये plane में stress है, plane में, and this is the out of plane f12. f12 is the out of plane stresses. Okay, so shear wall, it is the in plane shear force, axial force f11, in this direction f22, stiffness direction, this is the stiffness direction, which we have to consider. And out of plane stiffness, that is what, where is this what f21, it is the out of plane stiffness, or f12 you can consider it. Getting my point? And flexural stiffness, movement about this direction is very less, movement about this direction is very less, flexural stiffness is very less for the case of your shear wall. So here in plane stiffness f11, f22, f12, in plane stiffness. Out of plane stiffness will be what? M11, M22, M12. And for the shear M1, V13, V23, out of plane shear. Getting my point? So when you are going to define the when you are going to see in the ETABS software what it is asking for the case of slab.
You told sir F12 is out of plane stiffness.
No, wait. Let me show you. Go to section, go to slab section, go to modify, and here modify this. So your slab, what is it will carry? Let me show you. In the stiffness, I have defined it. Yeah, for the case of slab, what to do? Your slab is what? Flexural element or what? Tell me. Slab को actually आप क्या consider करते हो? Flexural element? Yes. For the case of slab, we are considering it as flexural element. So for membrane, for the membrane case, see F11, it should be F22, should be F22, it should be F12. In plane direction. So in plane having the more stiffness, very high stiffness is there, so that we are going to take into application. उसकी strength को हम लोग utilize कर लेते हैं 90%, 90%, 90%. So for the case of slab, I am going to define it as what? 90% consideration, 90% consideration, 90% consideration. Out of plane stiffness, for the case of slab is going to behave as a flexural member, तो उसको हम लोग यूटिलाइज कर लेते हैं, लेकिन 90% यूज नहीं करेंगे बिकॉज इट इज हैविंग वेरी स्मॉल डेप्थ, उसकी ऑलरेडी बहुत स्मॉल डेप्थ है. सो फॉर द केस ऑफ द स्लैब इट शुड बी व्हाट? 0.35 for the out of plane direction. Getting my point? Hello? यहाँ पर out of plane direction, it should be what? 0.35 for the serviceability case, 0.35 for the serviceability case, and this should be what 0.35 for the serviceability case. और if you are not getting, keep it to 1. इसको as it is रहने दो, मत change करो इसको. Actually slab is your flexural member, so flexural में out of plane. Yes.
इसमें जो मेम्ब्रेन लिखा हुआ है नीचे बेंडिंग लिखा हुआ है और ये जो F12 है F11 F22 तो समझ में आया कि दिस इज इन प्लेन है, बट 1-2 तो आप बोले कि आउट ऑफ प्लेन है.
आउट ऑफ प्लेन है. यस.
हाँ, फिर इसको इन प्लेन बता रहे हैं अभी.
No. Out of plane.
Please make it clear, sir.
Wait. Let me show you by the figure. Have a look. Look at this figure. Okay. This is the 1-1 direction. Clear? Sorry. These are 2-2 direction. Y direction 2-2 is the software is considering. X direction is considering as 1-1. Clear hai? Yes. In this direction, if you are going to find out the stress, suppose, wait. In this direction, along the depth, it is going to become a direction of 1-2. Got it? Along the depth.
Yes.
It is the shear stresses, means plane forces. It is the plane forces. ये प्लेन में फोर्स है एज एन एक्शियल, ये प्लेन में फोर्सेस था एज एन एक्शियल, ये प्लेन में फोर्सेस था एज एन एक्शियल. Like for the case of shear wall, the force in this plane as an axial, in this plane as an axial. Shear forces we are calling it to what? Shear. And flexural what? This is the flexural bending. This is what? Your flexural bending. In this direction, flexural bending. So flexural में उसका उतना स्टिफनेस है क्या, कैपेसिटी है, आप बताइए मुझे. For the case of slab,
I am talking about sir F12. Which is F12 here?
this is the F12.
But this is this is out. This is not the out of plane depth. F12 is.
No, that's what I'm trying to say. Forget about the see, just look at the type of the stress. This is the axial stress, axial force. This is the flexural movement. Getting my point?
This vertical force is axial.
No, see, it is the in plane direction. In this direction the movement will act.
No, this is axial.
No, movement will act in this direction. No, in this direction lateral force, shear force will come.
Okay.
Getting my point? In this direction high stiffness is there for resisting this.
Okay.
Yes. In this direction the lateral force is coming, suppose shear force is coming, and this span is there, so stiffness is there, 1-1, 2-2.
Okay.
Getting simple. Okay, now take the section. I am drawing one section here. This is the punching. Okay, for the plate element. This is the shear force at every of the point. ये shear force, ये भी जो है यहाँ पे horizontal force आ रहा था, ये vertical force आ रहा है. Getting my point? So
yes,
it
sir.
is a out of plane shear force. It is the out of plane shear force, not out of plane movement, flexural movement. Getting my point now?
Yes, sir.
अभी क्लियर हो गया? ये shear force है, knife or your bread. Getting? Hello?
Yes, sir.
Yeah, this is the situation.
तो इसको भी पॉइंट नहीं लेंगे अपन.
हाँ, अभी रुको समझो अभी पहले. तो यहाँ पर स्टिफनेस आपका ज्यादा था, तो हम लोग इसको इन प्लेन डायरेक्शंस, इसलिए मैंने उसको 0.9 ना करते हुए उसको भी 1 कर दो. आप इसको कंफ्यूज मत हो. नो नीड टू मेक एनी चेंज. इन प्लेन इट इज हैविंग अ फुल कैपेसिटी फॉर रेजिस्टिंग. गेटिंग क्लियर है ये? But for the case of flexure, your slab even we are considering it as what? Flexural member.
Now we got it, sir. For principal directions, we are considering 90%. For this section, we are considering only 35%.
Exactly. No.
Okay, sir. Okay.
But behind the concept is what? Yes. Behind the concept is that what is the concept? अभी आप load लगा रहे हो.
In plane direction, it is more stiff.
Exactly. So
Okay,
we are utilizing it. Why?
Okay,
if your if your member is capable of carrying the stress, so put the load over that.
Got
जब
it, sir.
उसकी
Got it, sir.
कैपेसिटी
Got it,
है,
sir. Got it, sir.
या व्हेन द सेक्शन इट इज नथिंग डिफरेंट, आपको जहां पर कैपेसिटी है, सेक्शन स्ट्रांग है, उसके ऊपर लोड डालिए. जब सेक्शन की कैपेसिटी नहीं है, सो प्लीज रिमूव द लोड फ्रॉम दैट पॉइंट.
That is, stress on the third direction is being distributed to the principal directions.
Yes, so
That is X and Y. X and Y.
in flexure it is less stiff.
Okay, sir.
फ्लेक्चर
Got
में
it,
लेस
sir.
स्टिफ है, तो मैं उसको रिमूव कर दे रहा हूँ.
Okay, sir. Got
only
it, sir. Got
only
it.
what I am going to consider, it is what going to be cracked when the load will come. So only it's what only it's 35% I am going to utilize. 70% I consider that during the flexural action it is going to be cracked. वो क्या हो जाएगा, क्रैक हो जाएगा.
Got it, sir. Got it, sir.
Clear? So here, if suppose you want to take 0.9, that will also, some of the consultants are providing it.
Yes, sir. Yes, sir. We can give 0.9, sir. 0.9.
0.9 or 100. Okay.
0.9. 0.9 we can give, sir. No issues.
Your choice. So okay, don't make
सर
changes.
सर ये बेंडिंग मोमेंट वन डायरेक्शन दिखाइए कहाँ पे आता है.
Okay.
बेंडिंग मोमेंट इन
मैं
वन डायरेक्शन
बताता हूँ. This is
एंड
what.
टू डायरेक्शन एंड वन डायरेक्शन का बेंडिंग मोमेंट किधर आता है.
See, this is the direction one. Clear? The bending moment in this direction, one.
ओके.
Bending moment in this direction, two.
टू.
Getting? That's it. For the case of slab element.
ओके. एंड वन टू.
1 2 bending moment will not be there.
But it is provided there.
Out of plane you can consider it. It is what, how we can present it, that need to check it. Okay. For the direction of this, okay, for this direction it is the bending moment. Out of plane we need to check that, sir. I'll see that for that direction. Okay, actually even in this ETABS software also the direction consideration has given. When you are going to see the help section, let's say, okay, uh, direction consideration by the plate. If you are defining F11, whether it is showing or not, I don't know. Yeah, see, getting, sir. But here for the moment it is not showing. For the only the direction consideration it is showing here. For the one direction, these are the faces and all. For the moment the plate for the case of plate it is not showing. Where it is, see, M11 direct movement per unit length acting at a mid surface of the element on a positive and negative one face. Positive and negative one face about the axis to direct movement per unit length. Okay, I'll try to demonstrate it with the figure. Okay,
Okay, sir.
I'll draw it. But I think you got the concept for these definition, right or wrong? अभी थोड़ा तो क्लियर हो गया ना ये प्रॉपर्टी मॉडिफायर का. Section property. Go to your slab section. Go to modify this. Go to your property modifier. So this correction is needed to do. Simply say okay. Then go to define. Go to section property. Go to your wall section. And in this wall section, now for all the walls, go to modify this. And here property modifier. Now for the case of property modifier, for the case of wall, have a look over this. What to do? Okay. Now see, here very simple. अभी बताइए, for the case of shear wall, for what purpose you are providing the shear wall in your structure, tall structure? For what purpose you are providing? Just for resisting the lateral force, shear force, yes or no? Okay, that is our intention, and our purpose is not to utilize your shear wall as a flexural member to consider the movement. That's why what we are going to do, we are going to release the flexural stresses. Point one, point one. For the shear also, shear. Okay, out of plane shears. In plane only the stiffness is there. उसका ही concern है in plane, because the shear wall is mainly provided for resisting the shear forces in plane direction. It is the case of your membrane. We would like to make it as what? Membrane. So membrane element will act as a stiff enough in their in plane directions. Getting my point? So for the case of here shear wall, we have to define it as what? 0. 0.9, 0. 0.9. Getting? And now out of plane stiffness we are not going to utilize at all. That's why 0.1 shear wall को हम लोग इसमें इन्वॉल्व ही नहीं कर रहे हैं. मोमेंट को कंसीडर ही लेना ही नहीं है, shear force को भी लेना नहीं है. shear force, okay, this is done. Mass and weight will be 100% to be considered. Then simply say okay. This is the property modification for your shear wall. Make it to 9, and we have to change it again once when we are going to design. It is for the serviceability checks. Okay, so it should be what? 0.9 should be 0.1. Can you mute your mic? Who is there, please? Okay, done.
So property modifier has to be applied separately for the service condition and as well as for the
Yes, correct.
So in that condition, you have to do the analysis for two different things.
Yes, for let's first ensure that for analysis case, sorry, for serviceability case, all the checks has been performed. Then finally go for the design. Okay.
Okay, sir. Okay, sir. Okay, sir.
Okay. This is the last one. And sorry. Take the copy of this, then paste over here. Paste over here. This is the 0.1. Copy this, paste it here, paste it here, paste it here, paste it here, and then simply say okay. Done. Now simply say okay. For the shear wall, for your beam, for your column, for your slab, for all the elements, we have defined the property modifier. Got it?
For the service conditions you have done.
For the service condition.
Okay, sir.
When we'll finally go for the design, we will correct for the ultimate case, because your IS code has suggested for two cases. Unfactored means for the service case, factored means your design case. That I have mentioned in the notes, that what service cracked and strength cracked. Okay, and this is for the uncracked case. 100% consideration of its all properties.